Make sure you have your calculators as well. So for recording purposes, today's areas of triangles, everything you need to know about it. So let's start off with two formulas that you might, I'm not saying you have, but might have heard of. Now, when it comes to the area of a triangle, the most popular one is base by, I don't like people saying base by height. The real term is actually vertical height. And that's a big difference. Because if you have a triangle like this, right? This here, if I call the base 11, and here's 6 meters, and this here 7 meters, right? So it's base by vertical height divided by 2. That's the most common formula. My question, sorry for going Australia. In this triangle, if I come and tell you the base is 11, what is the vertical height in this triangle? What is the vertical height to use in the question? Should I use the 6 as the vertical height, or should I use the 7 as the vertical height? Make the right choice. Let me see what you guys come up with here. Right, so some people didn't fall for the trick, right? It's a trick question. It's a trick question. None of them is the vertical height. None of them. You cannot use the 6 and you cannot use the 7. It's a trick, and the examiner will play the same trick on you. The vertical height is actually this line, this dash line. You see, the vertical height always makes a right angle with the base. This 6 and 7, I would call them slanted heights. Obviously, slanted heights is not the same thing as a vertical height. Now, right now, I don't know the length of the dash line, but if I give you the length of the dash line as 5 meters, well, now you could find the area of the triangle. Base, which is 11, the height, which is 5, well, vertical height, and then you divide it by 2. So don't fall for that in the exam. So I just want to repeat this something here. If I did not give you the length of the dash line, like if that was left out of the question, you cannot find the area of that triangle using this formula, the one on top. You cannot take it. You cannot do that, right? So let me just get started with the next formula. Another formula that's less popular, I guess, is to find the area of a triangle. It's a half multiplied by A multiplied by B multiplied by sine C, where A and B are the length of two sides of a triangle. You have to give it the length of two sides, and they must give you the angle in between those two sides. For example, if I have this triangle here, and I come and tell you this here is 7 meters, here is 12 meters, and I have, you notice I give you the length of two sides. If I give you this angle here, I come and tell you this angle is 95 degrees. Can you use this formula to find the area of the triangle? I gave you the length of two sides, so the two sides, you just call it common A and common B. So you could call this one A, and you could call this one B, or vice versa. It won't make a difference. Can I find the area of that triangle using the formula at the bottom of the screen? Is it possible to find the area? The answer is no, right? Because this 95 degrees is not in between the two sides. If I had put the 95 degrees here, well, now you could do what? Find the area of the triangle. You have the length of two sides, which is A and B, and C, capital C. You consider that to always be the angle in between the two sides. So could everyone just quickly, don't take down nothing as yet, right? Just quickly on your calculator, could you find the area of the blue triangle? Because you can't use the first formula, because the first formula, you need the base and the vertical height. You do not have the vertical height. you have a slanted height. So you're kind of forced to use the second formula. So quickly find the area of the blue triangle and send it on the screen there. Right? Don't take down anything as yet. I'll give you all a chance to take down everything. You guys know how I move by now. I will be very, very specific on what to do, right? And remember, you're finding area. So the answer will be in meters squared, right? Area is measured in something squared, right? Right? A lot of answers are coming up on the screen. So it's a half multiplied by the length of one side, the length of the other side. It doesn't matter if you put the 7 before the 12, and sine 95 degrees. Right? I'll put my answer over here on this side. 0.5, which is the same thing as a half, multiply by 12, multiply by 7, multiply by sine. Make sure I press the sine button, regular boring sine. And I'm getting 41.84 meters squared, right? Make sure your calculator is on degrees mode, right? So 41.84. Right. Right. So we're going to turn our attention to a right angle triangle first. So the first trick the examiner is going to try to play on you, right? In a right angle triangle, the hypotenuse, right? I think I mentioned this already. The hypotenuse is never a base or vertical height. It is never a base and a vertical height. In fact, the base and the vertical height are the two other sides. It will always be the legs. So in a right angle triangle, it's real easy to use the first formula, base by vertical height divided by 2. Well, in this green triangle situation, because the base is clearly 12, and well, they gave you the vertical height. So let's see what we get over here. The base is 12, the vertical height is 18, and divided by 2. Let's see what we get here. I'll work out this one for you guys. 12 by 18 divided by 2. We are going to get 108 centimeters squared. Quick question. For this green triangle, can I use this formula? Remember, the A and B represent two sides, any two sides, and C, this is a general formula now, right? Can I use this formula to find the area of that green triangle? Ask yourself, were you given two sides and the angle in between? Look at it. Yes, you can. Because you were given 18 and 12. Isn't this 90 degrees in between that 18 and 12? Look at it. 90 degrees is an angle, right? Do me a favor. Use the second formula now and tell me if you get the same answer, 108. Let me know if you will get the same exact answer. Answer. So it's a half. A and B, the two sides. You can put the 12 first or the 18 first. No, not the formula doesn't care. And the angle in between is 90. I guarantee you. Well, you will get 108 centimeters squared. Right? Take down the first question, and I want you to take down both set of workings to see, wait now, both formulas in this particular case give us the same answer, right? We're going to work out the yellow one together, but take 2 minutes for the green one. Right. Now, here's the thing, right? I'm supposed to put in the right angle. So let's have a look at what's going on here. Can we use the first formula, the regular boring formula? Area is base by vertical height divided by 2. Can we use that formula? One person said, yes, we could use that formula. I don't think we can use it, you know, because isn't the side opposite the right angle the hypotenuse? So remember, we mentioned, look, oh, I still have the note on the screen. The hypotenuse is never a base or a vertical height. So if let's say I call the 12 the base, I have no right to call the 18 the vertical height, the hypotenuse. If you dare disrespect the hypotenuse, the king hypotenuse, and call him a lowly base or a lowly vertical height, he will get angry and send you to the gallows. Okay? So we cannot use this formula. Well, not right now. Right. So can we use the other formula? Area is a half by A by B multiplied by sine capital C. Can we use that formula? Can we use that formula? One person said yes. All right, let's see if they are correct. So it's a half by A. They gave us the length of two sides. All right, 12 by 18. But I'm talking about right now. Number C is supposed to be the angle in between those two particularly given sides. Did they give us the angle in between the 12 and the 18? No, right? So they did not give, if they had given us this angle, like if they told us here was 45 degrees, fine, we could have used it. So we in a little predicament here. We can't use this formula. We can't use that formula. What are we gonna do, right? Well, let me put back this here. Somebody had said it a long time ago. If they gave us the length of PR, like I just said, I just say, if we could magically get the length of PR, and that would like solve all our problems. And we can solve our problem, and we could use Pythagoras theorem. A lot of people are telling me, but people were telling me that a long time ago. So do me a favor, guys, and everyone should be pros at this now. Find the length of PR using Pythagoras theorem. Right? I'll show you plenty different ways we can work this out and get the same basic answer. Same basic answer. All right. So to find the length of PR will be 18 squared minus 12 squared, and we square root that. 18 squared minus 12 squared. And when we square root that, we're getting 13.42 to two decimal places. Can we find the area now? Yep, because we have the base and vertical height values now. Remember, the hypotenuse is never a base or a vertical height. The other two sides of a right angle triangle are considered to be the base and vertical height. You can call any one the base, any one the vertical height, right? Just don't put the 18 in there. So quickly find the area for me. All right, let's see if I get the same answer as you. According to base 12, so the 13.42 will be the height. All right, let's see what we get there. Now, 12 multiplied by 13.42 divided by 2. And yes, you guys are correct. You get an 80.52 centimeters squared. How about if we use the other formula? How about this formula? Area is a half by A by B by sine C. Can we use that formula now to also calculate the area? Yep. So remember, A and B are the two sides, and C is the angle in between those two sides. So let's see if you can't choose any two sides you want. You have to choose two sides, but you must have the angle in between. If you do it correct, you'll get something extremely close to 80.52. You won't get exactly 80.52. You'll get something just extremely close to it. Because remember, this question has a whole set of rounding off in it. And we're using two different methods with different amount of rounding off. So our answer will look a little bit different. Right? So see if you could complete that for me. See if you can get an answer close to 80.52. Let's see if we get the same answer. Well, a lot of people are telling me they're getting the same exact answer. Well, that's good news. Now, the two correct sides to choose is the 12 and the 13.42, because the only angle we have right now is the 90 degrees, right? So we have to choose the two sides that are bordering the 90, okay? We can't choose the 18. So it will be half by 12 by 13.42 by sine 90, because the angle today, yeah, we're getting the same exact thing. We're getting the same exact thing. 80.52 centimeters squared. Take down everything, right? Make sure you have both ways to work it out. But there's a third way we could have worked this out. So when you take down everything on the screen, the two methods, I'm going to erase everything from the screen. I'm going to try it another way, right? However, if I come and tell you, I forbid you to use Pythagoras theorem, like you are not allowed to use Pythagoras theorem. In other words, you will never, ever be able to find the length of that side. Could we still get out that question? The answer is yes. Here's how we could easily get out that question. If we find this angle here, I put in a question mark by it, won't we have the length of two sides and we would have the angle in between? Couldn't we find this angle using sine, tan, or cosine? Obviously, you have to use the correct one. So do me a favor. Use sine, tan, or cosine and find that missing angle, right? It's up to you to choose the correct formula. So I guess substituting the values are half by 12 by 18, and we have the angle in between those things, and we get in roughly 80.26 centimeters squared. Right? If you round it off properly, it's 0.26 as far as I can tell. Right, so look how much different ways we were able to find the area of that triangle. And the only reason all the answers were slightly different is because we use different amount of rounding off. If we had used all the decimal places, all 8 decimal places for every single question, we will get the same answer. Right? Take out 20 seconds, take down my working if you need to, and let's move on. Right. So 2 more questions here, and I'm going to leave it up to you guys here. Let's see how much you can put together here. I'll put it in the right angle here. Now, these questions are not straightforward questions, right? I need you to find the area of each triangle. Please do not fall for the tricks, right? Remember, the hypotenuse is never a base or a vertical height. Also, each question, there are going to be more than one ways of working it out, okay? For the first one, I would prefer if you use Pythagoras theorem. So I'll put PHY here. For the first, no, sorry, no, you can't use Pythagoras theorem there. Oh, sorry. Go ahead. There's only really one way of getting out this question. Sorry. And there's only really one way, I believe, of getting out the second question, right? If you see a second way, you'll let me know. Take 5 minutes and send 2 answers. The reason I chose tan right? The reason for it, right, is that if I'm given the 58 degrees, the 22 is definitely opposite, and BC, which could potentially be the base, is the adjacent, right? Right? So I would use tan to find the adjacent side. If you want to find the adjacent side, remember, we block the A, and you're left with opposite divided by tan E, right? Well, sorry, tan theta, my mistake. You're left with opposite divided by tan theta, where theta is the angle you're standing up in. The length of the opposite side is 22, and the angle is 58 degrees. 22 divided by tan 50, that's not one. 22 divided by tan 58 is 13.7, that's not one. 13.75. I get in that if I round it off properly. So the adjacent side is 13.75. Anybody else saw that on the calculator? I've seen people sending that, right? So now check it out. Now we have the base and the vertical height. Remember, the base and the vertical height will touch the right angle. Remember, the hypotenuse is never a base or a vertical height in a right angle triangle. So let's find the area. Base, which is 13.75, multiplied by the vertical height divided by 2. Let's complete this. 13.75 multiplied by 22 divided by 2 is 151.25 centimeters squared. Right? Yeah, obviously you could use the other formula now, the half AB sine C, because you have the length of two sides now, and the 90 degrees is now the angle in between. So if you had used a half by 13.75 by 22 by sine C, don't put the 58, remember the angle in between the two sides we have now is the 90 degrees. And you will get the same exact answer, right? Good luck with the second. I know some people finished with the second question, but I think not, a lot of people now catching the beat of the question. All right. Now, there's a hard way to do this, the second one, and a slightly easier way, right? So good luck either way. This method. Meaning that if I have the hypotenuse, remember this 30 centimeters is opposite. So he is definitely the hypotenuse, right? The easiest thing for me to do is try to find this side here, which is the adjacent, right? That is the easiest way, meaning that once I get the adjacent side, I would have the length of two sides and the angle in between. How much people chose that way to go about it? That they just went straight and said, all right, I'll just find the adjacent side, then I'll just have two sides and the angle in between, right? And I'm only going to do it this method because this method is the easier of the two ways in my head, right? So what did we use? I think we have to use cosine, right? Because its cosine is adjacent over hypotenuse. We're trying to find the adjacent side. So adjacent is hypotenuse multiplied by cosine theta. So hypotenuse is 30, and theta is the angle that we're referencing everything from. So let's type in that. 30 multiplied by cosine 58. I'm getting 15 if you round it off properly to two decimal places, is 0.1590, because you have to add 1 to the 9, and then you get 10, blah, 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 right? So the adjacent side is 15.90 centimeters. Now we have two sides and the angle in between. The two sides are 15.90, the hypotenuse, which is 30, and the angle living in between is 58. Let's go. 0.5 multiplied by 15.90 multiplied by 30 multiplied by sine 58. 202.26 centimeters squared. Let's move to non-right angle triangles. This one should be easy. No one should get this one wrong. If this came in the exam for 4 marks, and this question here, no, it won't be with 4 marks, it'll be with 3 marks. Can you all find the area of this triangle? Just so, right? See if you can do it in under half a minute. What's the area of that triangle, right? I expect an answer from everyone. No one is supposed to get this one, right? The only thing that's different with this question and all the other questions is it just happens to be a non-right angle triangle. But you see this formula, to find the area, a half AB sine C. This formula doesn't care whether you use a right angle triangle or a non-right angle triangle. He doesn't care. Once you have the length of two sides and the angle in between those two sides, he doesn't care. He will work it out. And it seems to me we have that, right? We have two sides and the angle in between. Let's see. A half by 22 by 31 multiplied by sine. C is the angle in between 55. It's just a matter of typing in that straight on the calculator. 0.5 by 22 by 31 by sine 55, and we get in 279.33. For those who didn't get that, right? Sometimes you just do what? You just type in a number wrong by mistake, because late in the night you're tired or whatnot, right? But look for your mistakes, take down my working, let me know when you're ready. Right? So use the imagination. Somebody logging late to class now, right? Now we know, because we just work it out, over here is 22, over here is 31, and the angle in between is 55, right? But let's just say I erase this 55 degrees. So the person who now comes to class doesn't know that that angle is 55 degrees, right? And however, we tell them that the area of the triangle is 279.33 centimeters squared. Is there a way for this person to get back that 55 degrees? Let's make a bet with him or her. We say that if you figure out that angle, we'll give you 2 tickets to who's a very famous musician at the moment. You guys, I'm just gonna assume it's Taylor Swift, right? So we'll tell them we're gonna give them 2 Taylor Swift. I don't know who Kendrick is. Somebody suggested Kendrick. All right. So, all right. No, I'm not a Swiftie. I just know about Taylor Swift. All right. So, I don't know who Ken Carlson is. All right. So if somebody suggested to get back the angle, we do some kind of canceling out method. I'm not too sure what that is. But for 5 marks in the exam, let me set you all up. So they gave us the area and we have the length of 2 sides. Okay. So let's go to the same formula and start substituting in some values. Also, I'm not a fan of this half. Every time I use this formula on my calculator, you already think I just type in a half, or you think I just type in 0.5. And 0.5, right? If a 0.5, I'm going to choose that, right? So check it out. The person comes in class because he wants to win those tickets. He say, all right, they give me the area. So I'm going to replace area with 279.33. The formula is a half. I don't like fractions. Gonna put 0.5. I have the length of two sides because I'm trying to find the angle in between those two sides. So it's 22 by 31 multiplied by sine, and the angle we're trying to find is Q. So just officially, instead of calling it C, I'm going to call it Q. Everyone take down that up to there for me. He kind of doing it in reverse. He just taking the formula and he just substituted in what he or she have in the question. And hopefully he will be able to find that angle, right? Putting the little arrows here, right? So you can make the connection. All right, so let's dive a little bit deeper into this question here. 279.33. You think you are, and you all could multiply these three values for me? Multiply those three values, huh? Well, what's the sense keeping it as three values? We could just multiply it out and get one value. That should make life easier, right? 0.5 by 22 by 31. I'm getting, yep, people are saying it, 341 multiplied by sine Q. Take down up to there. Remember, we're trying to solve for Q. So we're going to transpose. We're going to try to make Q the subject because we're solving for Q, right? So this here, this 341 is a multiply. Throw across a multiply. You're going to get a divide. Divide this for me, right? Two 79.33 divided by 341. Anybody getting this here? Again, 0.819. Let's try to be a little exact, right? Because I want to try to get something as close. If you put 0.82, I will make a fuss, right? That is 0.189. But are we finished? Are we finished solving for Q? No. To solve for Q, you need to get Q on one side and everyone else on the other side. So we throw across sine. And what's the opposite of sine? Sine inverse. 0.8. Finish that out for me. Tell me if you get something extremely close to 55. We mightn't get exactly 55 because we did some rounding off. Second function sine, better known as the opposite of sine, also known as sine inverse, 0.819. And you get, look, you get 54.98. That's super, super close to what? 54.98, right? So the person win his tickets to whichever is the most popular artist and right now, right? You all can just use the imaginations, right? And this is a very popular question where you have to work back. Right. Let me see if I can trick you here. I want you to find the area of that triangle. It's trick time. Okay. Good luck. Remember, the area is a half by A by B. Some people saw through my trick. Well, it's already a trick. I tell you, it had a trick. So when I was talking in that tone, right? None of them is valid. You were given the 30 and the 43. You need the angle in between those two sides. You need this angle. I didn't come out right and tell you that angle, but isn't there a way to figure out that angle? I'll give you a hint. All the angles in a triangle add up to 180. Using that hint now, shouldn't it be super easy to find angle P? All right, well, you all are telling me, I'm reading the answers on the chat here. All right, so find the angle in between. Right, 55 plus 85 minus it from 180. You're getting 40 degrees, right? I just put in a little arrow here and how I got it is 180 minus 55 plus 85, in case you're wondering. So now we could go ahead and use the formula. A half, the two sides are 30 and 43. And C is the angle in between. That's Mr. 40. So you see how the examiner could be real tricky? He deliberately do this, He put out 55 and 85 to put your attention there, right? And he will make you think, oh God, just choose one, yes, anyone. But he trying to divert your attention, okay? So 0.5 by 30 by 40, that's all. 0.5 by 30 by 43 by sine 40. I'm getting 4.598 centimeters. I know you can round it off to 2 decimal places. You'll get 60 centimeters squared. All right. The examiner ain't gonna do you nothing if you go to 3 decimal places, right? He might actually be happy about that. Right, so don't fall for that trick in the exam, right? Take down what you need to, 20 seconds. Right, this one is our problem. Here's the thing. You have all 3 sides of the triangle and you want to find the area, but we don't have a single angle. Would it be, if, I just saying if you were to find angle Q, somehow, magically, would you be able to use the formula we just used, the half AB sine C? Like, if we just happen to magically find, yes. Now, you realize if we find angle R, we could use the 13 and the 20. If we find angle Q, we could use the 10 and the 13. If we find angle P, we could use the 10 and the 20, right? It doesn't matter which angle we find. We're going to get the same answer. But just to make things easy in the class, right? I want everyone to find angle Q. Quick question. We did this, I think, the week before. When you have all 3 sides of a non-right angle triangle, which rule can you use? The sine rule, the real hard-looking sine rule, or the real hard-looking cosine rule? It's the cosine rule, right? So I want everyone to use the cosine rule to find angle Q. And once you find angle Q, then you can use your regular boring half AB sine C formula. Okay, make sure I'm putting your common letters. I'll help you out a little bit. If here's capital Q, over here is common Q. If here's capital P, over here is common P. If here's capital R, over here is common R. Good luck, right? Take a 5 minutes. We want to find angle Q. So if you look back in your formulas, you'll see this here. Cos inverse. Let's put in the letters here. The two letters other than Q, remember, only common letters going to go in here is P squared, common P squared by common R squared minus common Q squared divided by 2 by common P by common R. How much people have the formula correct? You're supposed to build the formula to suit the triangle. Remember, if here is capital Q, the last letter here on top will be the common version of that. Make sure you have the correct formula, right? Make sure you have the correct formula. All right, let's plug in some values here, right? Remember, you have P here, so that's 13 squared plus 10 squared minus 20 squared. Common P is how much? 13, and over here is 10. Now remember, I think I had warned you guys, don't type in this straight on the calculator. Work out the top, write down the answer. Then work out the underneath, write down the answer, and then divide it. And afterwards, we will cos inverse it. So 13 squared plus 10 squared minus 20 squared. On top, I'm getting minus 131. And underneath, 2 by 13 by 10 is 260. How much people have those values somewhere in their working? Right, Kemi, you have it. Makela, Malachi, right? Natalie, right? Great. So let's divide it, right? So Q is cos inverse. Let's divide. Now we get a negative value here. You can't get a negative area if your final answer is a negative area. There's no such thing as a negative area, right? Let's divide it. 131 minus divided by 260. I'm getting minus 0.5038 or something like that, right? Now, if you go to two decimal places, right? Cos inverse, well, if you go to two decimal places, you'll get that. I don't have no choice if I'm going to two decimal places. Cos inverse, not 0.5, but negative 0.5. Are we getting 120 degrees? Now, if you use the 0.5038, you'll get something slightly different, right? But if you use the minus 0.50, that same exact thing, you will get 120. So guys, you all can finish off the question now, right? The angle in between is 120. You have two sides. You choose the two correct sides. You have two sides, and the angle in between those two sides is 120. You can find the area of that triangle now. The answer there for the area is 56.29 centimeters squared. There is a second way to work out this question without using the cosine rule. You're all interested in knowing that way? You think you would prefer a method, but it only works, it only works if they give you the length of all three sides, which is exactly what we have here. So I know you all would be interested in something like that. So let's move on, right? And now we come to something called Heron's formula. How much of you all have seen this in school? Heron's formula allows you to find the area of a triangle if and only if they give you the length of all three sides. This is on the syllabus, but it's very rare. But believe me, I've only seen this in my entire life, right? Seen this come like 3 times in the exam, as far as I can remember. But it's on the syllabus, and I don't want you all to get it, and I didn't teach it. I want you all to take down Heron's formula. I know it looks scary. You just take it down, and I will show you how to use it, right? Let me know when you're ready, right? This up. By the way, this formula is given to you on the formula sheet. So that is good news, right? You'll notice to find the area, you'll see letters A, B, and C. A, B, and C are just the lengths of all three sides. Okay, that is all. So it doesn't matter which one you call A, which one you call B, and which one you call C. You can call it in any order. However, S, the first thing we always need to do is find S. To find S is real simple. The formula says to find S, add all three sides and divide it by 2. Don't divide it by 3. I know it's a triangle, and your muscle memory will say divide by 3. Add all three sides and always divide by 2. So could you all find the S value for me first? Let's just get that off the table. Add all three sides, press equal, make sure you press equal, and then divide by 2. The answer will not be in degrees. S is, just find S. It has, don't worry about any units, right? So I'm adding 10 plus 13 plus 20. When I add it, I press equal and I divide by 2. And real people are sending what? Well, I'm waiting for more people to send it. Make sure I get involved in the question. right? Making sure we all have it here. Malik, check it back, check it back. Add all three and divide by 2, and you will get 21.5. Guys, remember, when you add the top, make sure and press equal and then divide by 2. If you don't press equal and then divide by 2, your calculator will make a mistake, right? So S is 21.5. Here's what I want you to do now. Go and minus 21.5 from all the sides. So all the sides go and minus 21.5, right? All of them. Minus, that's how we did this, correct? This divided by 2. Sorry, I made a slight mistake. I said it wrong side, right? All of them minus, take 21.5 and minus the length of each side from each of them, right? So go to each side and minus the length of the side from 21.5, right? So the 21.5 visiting all three sides, but when you go there, the length of the side gets minused from him. Right? So I'll start with the 13, right? 21.5 minus 13 is 8.5. For the side with 10, you get an 11.5. And for this side, 1.5. Everyone agrees with me? After you find S, S visits each side. But when he visits each side, the length of that particular side is minused from the 21.5. Right. So here's what you're going to do now. And I'm using the formula here, right? You're going to take the value of S. Remember, the value of S by itself is 21.5. And then you have to multiply it by 1, 2, 3. Those three things are these values. 1, 2, 3. But you're putting S first, huh? You're putting the S first, and then you put these three values, each with a multiply sign. So 8.5, 11.5, and 1.5. Multiply these four values, and when you get it, square root it. But square root it last. And once you square root it, you finish. That's the area of the triangle. And believe me, you will get something very close to the same answer we had just now. Multiply all four and square root it last. And the answer will be in centimeters squared, because that will be your area. Now, I get in something like this. You correct me if I'm wrong. Huh? When I multiply these four values, 1, 2, 3, 4, I got 3,152.44. Anybody can agree with that? When I multiply. And when I square root that, I get something real close to 56.15 or something like that. And we get back the same answer as when we use the hard cosine rule or something very, very close to it, right? This is Heron's formula, but it only works if they're given all three sides of a triangle. All right, try this one. Find the area of this triangle. Important first. S, when you add all three sides, 15, 30, and 19, we get 64. And when we divide it by 2, we get 32. Great. So what's going to happen now, right? Is that 32 is going to visit all three sides. So the 32 is going to visit here, 32 is going to visit here. 32 is going to visit here. But when he visits his side, the length of that particular side gets minused from him. So the 32 minus 30, then 32 minus 15, and 32 minus 19, right? So I'll put those answers in, well, I shouldn't need a calculator for this. 32 minus 30 is 2. 32, I need my calculator. 32 minus 15 is 17. And 32 minus 19 is 13. We have to put all four things together now. The formula says take the value of S, regular boron S, which is 32, and then these three values, multiply them after. That's what S minus A means, S minus B, S minus C. That's after you minus the length of each side. So you put 2, 17, and 13. You can put them in any order. It really doesn't matter. And then you square root that final answer. So 32 by 2 by 17 by 13. I'm getting 14144. And what do we have to do with that answer? Square root it. Let's see if you guys, the real people had it correct. But after you square root it, you get 118.93 centimeters squared. Make sure you physically see it on your